everyone, and welcome to our instructional video on graphing quadratic functions. So your quadratic functions are those functions that take the form ax squared plus bx plus c, where a can't be 0, because if this is 0, then this whole term will be 0, and your function will be just a linear one. It should be positive or negative. Anyway, and if any quadratic function of this form is in the general or standard form. And of course, the simplest quadratic equation that you might encounter would be the x squared, and it would be just the graph would be like a letter U. And then we also have the ax squared, and this one, your parabola would either be narrower or wider, or maybe it's upside down, depending on the sign of a. So it could be upright like this, or like this if the sign of your a is negative. And then we also have x squared plus k, where your parabola is shifted higher or lower on the Cartesian plane. It depends on the value of k. And then we also have x minus h quantity squared. This one, your parabola, the graph of the quadratic function, is shifted to the left or maybe to the right, depending on the sign of your h and the value. And then we also have this one is like a combination of these two. So this quadratic function right here is shifted to the left or to the right, and also maybe shifted higher or lower on the Cartesian plane. And finally, this is a combination of all the possible shifting, or being a narrower or an upright or a inverted parabola. Depends. So that's you have your a, you have your h, and your k. So we will be focusing on these forms for the next examples. So our first example is f of x equals x squared plus 2x plus 3. So how do you transform this into the form that we showed you earlier? So what we do is you complete the square for these first two terms. So you group them together, and then you complete the square by adding a constant term inside this enclosed term. But what do you add? If you have forgotten how to complete the square, and this is how we do it, what do you add? Of course, what you add, you have to subtract, because it should the equality, the equation should be still balanced. It should be as is. You can't just add or subtract as you will. So what you add, you subtract, so that we don't change the values. Anyway, so what do you add and subtract in this case to complete the square? Just remember, when you're completing the square, it's just this quantity right here. So it's b over 2 quantity squared. So what is your b? What is your b here? And your b would be this 2. So that's 2 over 2. We just exchange the b with 2. So 2 over 2 quantity squared. So you just get 1. So because this one would be 1. So 1 squared, this is 1. So this is what we add and subtract over here. And that would be complete. Your square would be complete here. But we have to take this away from the quantity. So we removed it from inside the quantity. It's like taking in a sense, it's like taking it outside of the quantity, outside the parentheses. So we could evaluate this. We have 2, negative 1 plus 3 is 2, and this one would be a complete. This would be a trinomial square, so it's just x plus 1 quantity squared. So then, when it is of this form, it's now in the form that we showed you before, ax minus h quantity squared plus k. So your a is 1, your h is negative 1, and then your k would be 2. So your vertex, it's very obvious from this form. It's just negative 1, 2. So the secret is the y component. It's just this one, And then the x component would be the additive inverse of this one. It's negative 1, 2. The axis of symmetry is x equals negative 1. It's just this one. It's just exactly the same. But how about the x and y intercepts? So we calculate that in the next slide. And here is how we calculate for the x-intercepts and the y-intercept. It's actually very easy. For the x-intercepts, you just let your y be equal to 0. So your f of x is actually just your y. So that's it becomes 0 because we let it be 0. 0 equals your quadratic equation, x squared plus 2x plus 3. So actually, if you want to have a little investigation on what your solutions would be, you could calculate for the discriminant. And the discriminant is just b squared minus 4. You actually don't have to do this all the time, but only if you want to. So calculating this, your b is 2, your this is a constant, and your a is just 1, and your c is 3. That's where you have it. And calculating this, we get 4 minus 12. This is 4 minus 12 equals negative 8. And negative 8 is obviously less than 0, so we're actually expecting that the solutions to this equation are not real numbers. They're imaginary numbers because the discriminant, negative 8 is less than 0. It's negative. So let's verify that. Our x-intercepts is none or does not exist or not available, or just put it in there are no x-intercepts. But let's verify this one, this if it's really negative. So you have your quadratic formula right here, negative b plus or minus this quantity over 2a. So your b is just 2, and your a is 1, your c is 3. And you have this. And calculating this, we have this one. So obviously it's square root of a negative number. It's true that it's going to be an imaginary number, whatever this value is. But we don't really have to calculate that because it's an imaginary number. Okay, how about the y-intercept? So for the y-intercept, it's even easier than the x-intercept. So just let your x be equal to 0. So all the x's you turn into 0. So it's just y equals 0 squared plus 2 times 0 plus 3. This would be 0, 0, and it's just 3. So your y-intercept is x0, y3. So again, our example, the quadratic function, this is our given. This is actually what our given. We came up with this by completing the square. The vertex is negative 1, 2. Axis of symmetry, x equals negative 1. No x-intercepts, and the y-intercept is 0, 3. And then I have already graphed it here. And there's your vertex, there's your intercept, and there's your parabola. And this is your axis of symmetry, x equals negative 1. So the graph confirms our calculations. But now there's actually another way, a different way on how to get your vertex, your axis of symmetry, and it's just using this. The vertex is it's just negative b over 2a and 4ac minus b squared over 4a. These formulas right here, they're actually derived from the general form, the standard form of a quadratic function. But that's not we're not going to go into that right now. Okay, anyway, so how do you use these formulas? You just insert whatever your b is, whatever your a is, and whatever your c is. And negative b over 2a, this one, the x coordinate of your vertex, is this one, negative b over 2a. Negative is this one, your b is 2. So 2 times 1 because your a is 1 here. Here a is 1. So negative 2 over 2 is just negative 1. How about your 4ac minus b squared over 4a? This quantity right here, your y coordinate. So calculating that, we have 4 times 1 times 3 minus 2 squared, or all over 4 times 1. So all these numbers right here, it just came from this one. So calculating this, with a 12 minus 4 over 4, 8 over 4 equals 2. So your vertex is negative 1, 2. So this one we got from this 2 and this one. And we just solve this formula right here. And that's how it looks like when we complete the square. So let's have this second example of that. 4x squared plus 8x minus 5. What you do first is group together the first two terms. You have quantity 4x squared plus 8x minus 5. And then we factor out a common term for this, a common constant for these two terms. So that's just going to be 4. So we factored out 4. So we have x squared plus 2x. So completing the square of this quantity here, this expression here, we have add plus 1 minus 1. So it's not always 1 minus 1. It depends on the value of your b. Now when we remove this, when of course we want to remove this negative quantity so that we could complete the square. When we remove this and you have a constant here, it has to go through that like this. So when we remove this one, this quantity, negative 1, we removed it from the quantity, it has to go through 4. So it has to be multiplied by 4. See? So it's negative 1, multiplied by 4. So now we're free to factor this because it's a perfect trinomial square, perfect trinomial square. And then we just multiply and we add or subtract whatever we have here. And that's just 4 x plus 1 quantity squared minus 9. It's now of the form a x minus h plus k. So your k is negative 9, your h is negative 1. Alright, so continuing, we have f of x equals 4x squared plus 8x minus 5. We have calculated to be 4x plus 1 quantity squared minus 9. So the vertex is obviously negative 1, negative 9, because your negative 9 is there, and negative 1 came from here. So you could just imagine that the x-coordinate for the vertex is like the additive inverse of this constant. It's like the opposite of this constant, the opposite in sign. The axis of symmetry is just x equals negative 1. It's just this one. So what are your x and y intercepts? So let's calculate. Your x-intercepts, again, you just let y be equal to 0, and then you solve. So 0 equals 4x squared plus 8x minus 5. That's just this equation here. And you could actually factor that, 2x minus 1 times 2x plus 5. And your x would be 1/2 negative 5 over 2. So these are your zeros for this. So if you're not still not used to factoring, you could again use a quadratic formula. So using the quadratic formula, your negative b squared minus 4ac already calculated. So I calculated it, so you could do it on your own. You could pause the video and solve this for yourself. Try and see if it's correct. So continuing, we have negative 8 plus or minus square root of 144. So we just added this, and the square root of this is 12. So we're going to calculate it at plus and minus. This one is negative 8 plus 12. This one negative 8 minus 12. So this is just going to be 4 over 8, this one. And this is going to be negative 20 over 8. This would be 1/2 and negative 5 over 2, which is exactly the same with this one. So your x-intercepts are, it's just the same. So your x-intercept is 1/2 0 because your y is 0, negative 5 over 2 0. How about your y-intercept? It's just even easier. Let x be equal to 0 and solve for y. So y is equal to 4 times 0 squared plus 8 times 0 minus 5. Obviously, this will be 0. So your y is equal to negative 5. Or y-intercept is 0, negative 5. So this is the summary of our answer for number 2. The vertex is negative 1, negative 9. Again, you could solve for the vertex and the axis of symmetry using the formula that we showed you earlier in the video. And the x-intercepts are 1/2 0, negative 5 over 2 0. And you can see it here. See? Negative 2 and negative 2.5, and this one half 0. And this is your axis of symmetry. So let's have another example. So number 3, f of x equals x squared minus 6x minus 2. So again, we group together the first two terms, x squared minus 6x, and then you complete the square, b over 2 quantity squared. You add and subtract inside, so that's just plus 9 minus 9. So you could verify, solve on your own what b over 2 quantity squared is. It's just going to be 9. It should be 9. So when we remove this from the parentheses, because like that, so we don't multiply to anything because there is no constant. Yeah. It's just a constant one. Okay. So now this is factorable, and this we could just add over here. So x minus 3 quantity squared and minus 11. So it's in the form. It's in that form ax minus h plus k. So this is the given. It's of this form apparently. Our vertex is 3, negative 11. So 3 because the additive inverse of negative 3, or the 0 of this expression. The axis of symmetry is x equals 3, and we solve for the intercepts. For the x-intercept, we let y be equal to 0. Let y be equal to 0. And then we have this 0 and x squared minus 6x minus 2. Just this one. And then we solve for x. Solve for x for here. Although you could check, but it is not actually factorable. I don't think it is. So I proceeded with the quadratic formula. This is negative b, or b is negative 6. Okay, be very careful with the signs. Okay, so this is negative 6 squared, so I already evaluated it at 36. Negative 4 times a, is 1, and c, which is negative 2. And your denominator 2a, so your a is 1. So solving this, so again, be careful with the signs. So this is positive 6, and 36, nothing happens. Negative 4 times 1, negative 4. Negative 4 times negative 2, so that's positive 8. And we have 6 plus or minus 36 plus 8 is 44. And denominator gets copied. And then this is just 6 plus or minus 2 square root of 11 over 2. So we could divide by 2, and that's just 3 plus or minus square root of 11. So this is an irrational number, so there's nothing more we can do about that. So your x-intercepts would be 3 minus square root of 11, because remember, this is plus or minus. So 3 minus square root of 11, 0. 3 plus square root of 11, 0. It's really just, it's like just copying this into the x coordinates. Just changing the signs, and then putting 0 for y. Okay, how about your y-intercept? So let x be equal to 0. So that's just 0 squared minus 6 times 0 minus 2. Where did I get this? Again, we substituted x to be 0 into our equation. So you have your y as negative 2. Your y-intercept is 0, negative 2. Very easy. So here is the summary for your number 3. F of x is equal to x minus 3 quantity squared minus 11. We calculated that before. The vertex is at 3, negative 11. So that's this 1, 2, 3, and negative 11 is way over here. So there is your vertex. Axis of symmetry, x equals 3. Yep, it verifies. Your x-intercepts, yep, it actually intercepts the x-axis over here. And your y-intercept to be 0, negative 2. Alright, so now our fourth example. F of x equals negative 3x squared plus 12x plus 1. For this one, it's just the same method. Group together the first two terms, negative 3x squared plus 12x. So if it helps you with the parentheses, please do. Actually, I think it would. Now there's a common factor for these two. and it is -3. So we factor out -3, it becomes x squared minus 4x plus 1. Okay, so complete the square with this, and it's b over 2 quantity squared, remember. So it's going to be plus 4 minus 4. You could calculate that on your own if you like. So now we remove this from inside the quantity. So when we removed it, again, so it's -4, it has to go through -3. So -4 times -3, positive 12. That's what happens when it tries to go outside of the parentheses. When you could imagine it like when it tries to go outside the parentheses, it has to go through that guard outside the -3. So -4 times -3, you get positive 12 plus 1. And this one is factorable, perfect trinomial square. And this one just add it. -3 x minus 2 quantity squared plus 13. So it's now of that form again. So this is your number 4. This one, the same. And this is what we just calculated. The vertex is at 213. So 2, uh, the additive inverse of this, 2 and 13. Axis of symmetry, x equals 2. And what are your intercepts? We will calculate it now. Okay, so your intercepts. So for the getting the x and y intercepts, it's exactly the same method as the previous ones. For the x-intercept, let y be equal to 0. So 0 equals your expression. And alright, I tried, but I can't find any factors. It's actually not factorable. So we use the quadratic formula. X equals -b, your b is 12, plus or minus b squared, 144, minus 4ac, your a is -3, your c is 1, all over 2a, and your a is -3. All right. And evaluating this, we have -12 plus or minus the square root of 144 plus 12. So be careful with the signs, multiplying and adding stuff. And the denominator would be 2 times -3 equals -6. So adding what's inside here, we get 156. Now you could actually stop right there with this quantity, but for me, I like to simplify it to the simplest form possible. So I evaluated this as 2 times the square root of 39, and then there's a common factor for these three, which is -2. That's why I divided it. So the common I divided it. So -6 divided by -2, 3, -12 divided by -2, which is 6, and 2 divided by -2 is actually, this should actually be inverted, but it's pretty much the same. Nothing really changes. It's just plus minus. Okay, so again, your x-intercepts would be the -1 and the +1. Okay, so 6 minus square root of 39, and this one 6 plus. And those are your x-intercepts. With the y-intercept, the easy part, just let your x be equal to 0. That would be the calculation. So the first two terms will be automatically 0, pretty much. And you will be left with 1. So your y-intercept is 0, 1. Alright, so here's the summary for your number 4. So this one is -3, x minus 2 quantity squared plus 13. So again, we got this by completing the square for this one, for the first two terms. The vertex is 213. So 213, you can verify that in the graph. 1, 2, and all the way to 13. See? So that's the highest point. Axis of symmetry is x equals 2. There it is. Your x-intercepts are these values. So the issue is pretty much, it's right here. These parts right here. Those are your x-intercepts. Your y-intercept is 0, 1. The x is 0 and y is 1. So pretty much, it really verifies. Alright, and that's pretty much the end of our video. And it's actually very easy graphing quadratic functions. So with functions like these, you could rearrange them and complete the square and come up with this form. And it's from here, it's very easy to get the vertex and the axis of symmetry. So your vertex is just hk, or you could also use that formula that we showed you with this negative b over 2a for ac minus b squared or 4a. So if you don't want to complete the square, but you want to get the vertex, you can just do this right here. So these are your friends. All right, so that would be the end of our video. Goodbye and see you on the next video.